its principles. So it composes objects into a tree structures to represent the hierarchies, and it let client applications treat individual leaf objects and composition of objects uniformly. So here what it tries to explain is, um, let's see this scenario. Developer designed to represent the hierarchy of objects in an online shopping menu list. So when I say it composes objects into tree structures to represent hierarchies, what essentially I mean to say is, look at this. Suppose if you go to a online shopping application and you try to purchase a few dress items. So at the top you see category as all dress items, right? And when you expand that, you get its subcategories such as trousers, shirts, jackets. And then when you expand it further, you get few more list of items: trouser of brand 1, trouser of brand 2 and 3, and similarly for shirts, brand 1, brand 2, brand 3, and same for jackets. And it has one more subcategory which is offers, which means all those dress items are related to trousers which have an offer attached to them. So if you click further and expand the tree, you will get few brands which are having offer on them. So if you see, this is my tree structure wherein I have various leaf nodes which are the individual dress items and few categories as well, such as offers on trousers, and trouser itself is a subcategory of all dress items. So all these blue highlighted ones are the categories and the green ones are my leaf nodes. So the blue ones are my dress categories and the green ones are my dress items. Now let's have a look at this again. So I said it composes objects into a tree structure to represent hierarchy. So now if I have to design, I have to make a design so that all my leaf nodes, all my dress items, all my dress categories can be organized into a tree structure. So there we can make use of composite design pattern. It also lets client applications treat individual leaf objects and compositions of objects uniformly, which means client applications does not need to know which is my leaf node, which is my or which is my individual dress item, or which is my dress category. There should be a common method invocation to list all these dress categories and dress items. So we are going to say this, how we are going to implement this via code. This scenario, I have to represent the hierarchy of objects in an online shopping menu list. But before that, suppose if you have to design this without knowing the composite design pattern, and you have to maintain uniformity between the individual dress items and categories, then how you are going to do that? Are you going to create individual classes for, say, trousers, shirts, jackets, and there can be a number of such subcategories inside all dress items, and are you going to create further subclasses or subclasses of trousers, and one for brand 1, brand 2, brand 3, and then again you will have a class for offers with trousers, offers with shirts, and you do this. So it will lead to a large number of classes in your code, and um, you won't be able to maintain a uniformity, which is one of the principle, or which is one of the use case which I want. Let client applications treat individual leaf objects and compositions of objects uniformly. So when this is a requirement, then you go for composite design pattern. So let's see some code for it. So first of all, we are going to define an abstract class or interface to lay out the behavior of my concrete classes. So in this case, my concrete class will be a dress item and a dress category. So this dress item is going to represent these leaf nodes, these individual dress items, and dress category will be represented by these subcategories, the highlighted blue ones. So if you see, I just have one abstract class and two concrete implementations of this abstract class, and with this only I'll try to pull the hierarchy of this tree-like structure, right? So let's see how. So the first thing in my abstract class, I'm going to define all the methods which can be overridden by my concrete classes, which are the nothing but all the um, behaviors that my concrete classes are going to have, right? If you see, I have a method called add remove. So this will be primarily used by my dress category class in order to add one more subcategory, or in order to add one more dress item, right? Get child again will be used by my dress category. Get name also. Get name can also be there at the level of the dress items plus at the level of the category also. Same goes for get description. Get price will be used only by my dress item, because category will have no price. Price will be tagged against each individual dress item. And a print method to list various features such as name, description, price. So if you see here, I'm by default, when I'm putting these methods in my abstract class, I'm providing a default uh, logic here, which is to throw a runtime exception. Why? Because not as I said, there will be two concrete implementations of dress component, dress item and dress category, and all these methods will not be um, valid for each of the for each concrete class. As I told, like individual dress item cannot add further dress components to it, right? So in this case, if client calls calls this add method over dress item, then it's going to give throw a runtime exception, which is unsupported operation. So this is a slight trade-off, I will say, that we are doing. we are unnecessarily binding the concrete class to behavior which it is not supposed to have. But this is, as I said, a trade-off with composite design pattern against the general design principles. And this trade-off we are doing because of our specific use case, our specific scenario where we want the client applications to treat each individual leaf objects and compositions of objects uniformly, right? So what else is like, let's go to the concrete implementations. We have a dress category. Let's first talk about dress item. So it extends this dress component abstract class. It has a name, description, and a price, okay, as data members. And whenever I'm going to create any object of dress item, I'll pass it to its constructor, name, description, and price. Here I have simply overridden these methods: get name, get description, and get price of dress component. And I'm just going to return the name of this dress item, description, and price. In the print method, I'm just going to display the name, description, and price. Simple, right? So this class, as I told, dress item represents all the leaf nodes, all the dress items which have no further childs, right? Now coming on to the dress category. It again extends dress component. It has a name and a description, no price, because a dress category cannot have a price. It's it like dress category can have further dress items which can have price, but dress category can't have a price. So, and it also has a list of dress components, right? So what this list represents is, if I talk about this trousers, so this is the list. So brand T1 is a dress item which extends dress component and offers, though it is a dress category, but it also extends dress component. So I can uniformly put it as list of dress components, right? So it's going to have this list, and whenever I'm going to create an object of dress category, I'm going to pass dress this name and description. And I have a method here, add, where I'm going to this list, I'm going to add any new dress component. Like this is a dress category and I'm adding further dress components to it. Similarly, I can remove also, and I have a get child. So if I'm interested in any of the specific child of this category or this dress category, I can get that. Then get name, get description, and in this in the implementation of print method and dress category, I'm going to print the category name, category description. Then I'm going to iterate over all the dress components which are under this dress category, and I'm going to call the print method over individual dress component, which means if this is my dress category, these are its childs or children, 4 dress components, of which 3 are dress items and 1 is dress category itself. Then it's going to call the print method of each of them, right? So that's what it's doing. Now, like every tree, I need to maintain or get the info registered that which is my root element, right? So in this case, this is my root element, all dress items, which is nothing but a dress category only, which extends dress component. So I need to get hold of this somewhere. So for this I'm going to create a dress root component, and here when I'm going to create its object, I'm going to pass a dress category to it, right? And I will assign it to this root. Okay, and then I have a method called printall, which is going to call the print method of the root, which means print method of the dress category, which means print method which is listed here. Okay, so it's going to print category name description, and then it's going to iterate over all its childs, and it's going to call the print method over each of them. So let me have a test class to demo this. So here if you see in the main method, I'm creating a object of dress category which is trousers, and I'm going to pass the name and the description. So what essentially I'm doing is creating an object of trousers, right? This one. And then I'm going to create an object of again a dress category, shirts, which is this one. I'm going to omit this jackets part from my code, so that code is less. Then there is another dress category which is trousers on offer. So all this, as I said, blue ones are the dress categories. So I have one more dress category, offers on trousers like this, and again I'm going to name it trousers with offers with a description, trousers of various brands with offers. Similarly, or shirts on offer, again a dress category, right? So by now I have created 4 dress categories objects: trousers, shirts, offers, shirts offers, and trousers offers. Now I'm going to create the root. So here I am doing that all dresses, which is again a dress category, all dresses of various brands, right? Name and description. So this is my dress category. So this is the root, all dresses. So I'm going to pass it to the dress component, dress root component here, and I'm going to maintain the root at the level of this class. So here I say new dress root component, and I pass this all dresses object to it. And then to this all dresses object, this one, what I'm doing is I'm adding the components. All dresses dot add trousers, all dresses dot add shirts. So here I'm binding all dresses dot add trousers, all dresses dot add shirts, right? And then to the trousers I'm adding more subcategories or dress category, such as trousers dot add trousers on offer, shirts dot add shirts on offer, something like trousers dot add trousers on offer, shirts dot add shirts on offer. And then I'm going to add individual dress items. So these were dress categories. Now I'm adding dress items. Trousers dot add new dress item, trouser brand A and its description and a price, right? Similarly, I'm adding one more to the trousers, new dress item. Similarly, I'll do it for shirts also, and similarly I'm going to do for trousers on offer also and shirts on offer also. I'm adding dress items. So what I'm doing here, to this just dress category I'm adding dress items. To this dress category shirts I'm adding dress items. To this category trousers on offer I'm adding dress items, and similarly for this one. So once I'm done all this, I will just simply call dress root component or print all. Okay, so what it's going to do, it's going to go to this root component and execute this print all, which will go and on the root object it's going to call print. What is my root object? My root object is, as I told, this one, all dress items, which means my root object is if I go to my test class, as I told, all dresses, right, to which I am adding trousers and shirts. So it's going to call the print method here. So dress root component, I mean this all dresses is of type dress category. So it's gonna go here and call this print. It's going to print this category name description. It's going to iterate over all its subcomponents and it's going to call the print methods. And once it does, so if you see individual subcomponents, which means in individual dress categories or dress items, essentially it's going to call the print over each of them, because child of this is trouser, so it's going to call the print over trouser object, which is again a dress category only. So what it's going to do is it's going to again call the print method over its subcomponents, which means subcomponents of trousers are these. It's going to call the print of brand 1, brand 2, brand 3, and then this is again a dress category, so all these were dress items, so it's simply going to first print name, price and description. Then since my offer is a dress category, so it's going to again call this print here, and it's going to iterate further the leaves or the subcomponents of this dress category, and it's going to call the print. So further, if you see this offers has these three dress items, so it's going to call the print of this. Okay, so in a way I'm trying to call the print method over each of the dress component, whether that dress component is a dress item or a leaf node, or that dress component is a dress category, right? So in a way I am treating all my leaf objects or dress items or my dress categories uniformly, right? So let's try to run this. So let me see what it has printed. Okay, so as I told, let's make it like this. First it printed all dresses with various brands. From where it came? It came from this guy, all dresses name and category description. So it printed this thing, right? And then it went on and did the same thing for trousers, because to this all dresses I'm adding trousers here. So it executed a print of this dress category, and it printed this category name trousers, category description trousers with various brands. But then here what I'm doing is I'm iterating over the this dress components, and the same thing it did for the root element also. So it came here, because my root element all dresses is nothing but a dress category only. So it first printed all dresses, category name all dresses, category description all dresses with various brands, and then it iterated over the dress components, which were trousers and shirts. So first it printed the same for trouser, and then trouser has further more childs or dress items and categories attached to it. So now it is iterating over those. So it printed trousers with offers, which means after doing the print for this, it's doing for this. Okay, and trousers with offers only category and description, because it is a subcategory. Then here it is printing the print statement, which is the print statement details, which is in my dress item, which is this. So it says name, description, and price. Why? Because um, when I got the element of this trousers with offers, while printing its executing its print method, it further will go down and find all the dress components attached to it, which are this, right? Childs of offers. So it's going to now, why dress item? Because this dress component dot print, when it's going to execute, this dress component will be not my dress category, it will be my dress item. My dress category and dress item both extends dress component. So now it's going to go to the leaf or the dress item and it's going to print this, right? So similarly it's going to print this trouser brand F, trouser of brand F with offer price. Then trouser brand A, trouser of brand A, it's not with the, it's not a child of offer, uh, right? So what it is printing is this one, right? So it goes like this. So it, from here it came here, from here it went here, printed all its childs, and then it's going to print this, then it will go to shirts, print this, then it will come here, first print this and its child, and then this. So which you can correlate with the this output, right? So you must have seen that in order to display the hierarchy, if I used a composite design pattern, I'm able to do this with bare minimal classes, right? Dress item, my leaf nodes, dress category, all those nodes which are having further leaf nodes, right? And a root component to maintain the root category, right? Or a root dress category, and an abstract class, obviously. Um, so with this I'm able to achieve whatever is was mentioned in a scenario, like to represent the hierarchy of objects in an online shopping menu list, and letting the client application treat individual leaf objects and compositions of objects uniformly, and I'm able to display the tree structure also. Okay, but while I was going through this design pattern, I found that it, as I told, it has done few trade-offs, right? The first one, I am unnecessarily making my subclasses extend a abstract class which is having few methods which are of no use for my subclasses. Ideally it should not have been done. So yeah, that is one of them. And again, the principle of single responsibility, um, keeping the trousers, shirts, and all such subcategories under one class, which is dress category, right? But as I said, it is a kind of trade-off. When your requirement is just to like maintain a tree-like structure and let the client application use your design to maintain a uniformity between all the categories and leaf nodes or the individual items. Okay, so in such cases you can go over this composite design pattern. It was a little code, if you see and all, it might turn out to be little complex, so You can go pause this video and go over the code once again and try to connect the dots between this principles type of scenario when you should use it, and the main classes or abstract classes or interfaces that lets you achieve a design using the composite design pattern. Okay, thanks a lot friends.